Welcome guys. So in our last video we have seen how the recursive Fibonacci function works, the time taken basically for the CPU complexity or the CPU time taken by the different languages. Now the same thing I am doing, but not in the recursion. I am using an iterative approach in this one. What I am doing here is basically I am just taking two numbers. Okay, and then I'm just creating a new number and I'm replacing the numbers accordingly, so that the latest calculated Fibonacci is always gets the one, and the second latest goes to the Fibonacci sequence of zero. I'm just creating this add up. Okay, so that's what. Okay, it's very simple algorithm. So now let's run this. So I already have compiled everything. So let's take the time comparison. So first I'll run with the C1. So it's calculating 701408733. Why I have chosen particularly 45 is because beyond that it's getting integer overflow. So this one is very low in the CPU time. So it even comes in microseconds. So it cannot recognize the change. So it's coming as zero. Okay. Now let me do it with the Rust. So Rust, it takes 91 microsecond. So crazy optimized version basically. Java takes 11 milliseconds to do the same. Let me do it with Node now. Node takes 6.49 milliseconds. Okay, and let me just run the last one with the Python. Actually, I got little surprised when I first ran the Python one. You will also get surprised. Okay, so this one takes 0 milliseconds to calculate. Okay, now let me bump up the number in the Python file. So I have even bumped it up till 4,000, 45,000, and even with that number also Python, no, sorry, not 45,000, 5,000, sorry, only 5,000. Even with that also, just pretty much optimized. It takes just around 3 millisecond maybe. So this is really a surprising factor for me. I don't know how it happens, but yeah, something that I think I should talk to you guys. Let me do the same thing. I haven't actually done this, so let me do the same thing for 5,000 also. I don't think it will work with Node or Java and or all this, because I mostly think that there will be some integer overflows. Yeah, it goes to infinity with 5,000. Let me just try with 500. 500 came up with some result, but it's pretty high. So don't go to this Fibonacci. Okay, I should have written a better code here to just take the whatever number here. But yeah, I mean, you guys are getting the point, right? So 500 also, it's running pretty high, within 6.873 milliseconds. Now let me do the same thing with Java. Probably there should be something here. I don't think it will calculate the Java one with this range of integer. It will go haywire. Okay, but still, there is no harm in trying. This is not for the actual result. So yeah, it obviously went for an haywire. The integer overflow took place and things like that happened. Let me just try to do it a smaller number, not maybe not let's say maybe 100 only. Okay, this is not about getting the perfect result, but it's more of getting the performance, right? Yeah, here also till 100 it takes just 12 milliseconds to calculate 100 Fibonacci numbers. Although it's not correct, but yeah, you get the point. Okay, let me do the same thing. Let me try the same thing now with Rust. Okay, Rust. Let me try that. Rust. Let's try with 100. See, I know it will go for integer overflow. I think Rust also will go for integer overflow, but let's just try one. Okay, Rust C test. I have not run it for this is the first time I'm running this. So I also may be surprised by the result. Yeah, Rust actually panicked with overflow. So attempt to add with overflow. So 100 obviously didn't go well with the Rust. So Rust has this overflow concept. So um, yeah, so there are flags that you can use to just get out of this overflow, and you can actually perform something. Here also it seems It's doing the same thing. I think 45 or 49, 50 was the limit where we can do it with just the simple integer, I32 integers. I think, yeah, 59 was the limit. If I'm not wrong, I think by 49th Fibonacci series number should give us, oh, not even 49. Nice. 48. 45 we ran, so we know that 45 it will work. 49, let me just try once. What happened? It 48. Did I run it with Fibonacci? I know it. I didn't. Yeah, here also it failed with 48. So let me just try with 47 once. I'm just trying to figure out the breakpoint. Yeah, 47 is the one which actually is coming with the integer range, and I can actually now see that it's having showing me the result of 108 microsecond. Okay, let me try with C1 also now. So let me just try once with the C if it works. Just dot C minus O test hyphen C dot slash test hyphen C. Yeah, C also works with 47, and I think it also takes around what 100 microsecond. I don't know what this is becoming, but yeah, it's pretty low in number. Okay, so yeah, these are the results for running this optimized version of Fibonacci series. Okay, thank you. In our next video, maybe we'll look into some more algorithms. Okay, thank you.